In our last standard, we talked about sequences. We can form a series when we add the different terms of a sequence together. Therefore, we can form an arithmetic series when we add together the terms of an arithmetic sequence. We can do that using this formula. Most of the time, you're going to be given a problem written in this notation, and you have to do a few things to be able to convert this notation and use this formula. This notation is called summation notation. This is the capital Greek letter sigma. The first thing you're going to do is find a sub 1 and a sub n. This value is going to help us find the first term. That value will be substituted in for the variable and will give us the first term of the series. We can find the last term by taking this value and substituting in to find the a sub n term. Once we have a sub 1 and a sub n, we can find n by subtracting the number on top and the number on the bottom and then adding 1 to it. The number on the bottom and the number on top tell us which terms of the sequence we are going to be finding the sum of to form our series. We're going to start by finding our a sub 1. This means that we're going to take 1 and substitute it in for k. 3 times 1 minus 2 gives me 1. Then we're going to find our a sub n. A sub n would mean we're substituting 10 in for k. 3 times 10 minus 2. Then we need to find out what value are we going to use for n. How many terms are there going to be in the series? We'll take 10 minus 1, which is 9, and add 1 back to it. That gives us 10 terms in the series. We cannot always just look at the top number because it won't always be the same. This is particularly true if our series does not start at term 1 from the sequence. Now we can substitute into the equation. The sum of the 10 terms is going to be equal to 10 times the first term, which is 1, plus the last term, which is 28, and all of that will be divided by 2. 1 plus 28 divided by 2 times 10. So the sum of these 10 terms is 145. Number 6. We can find the first term by substituting 1 in for n. And we get the first term as 7. The last term of the series we can find by substituting 8 in for n. And we get negative 14. If we take the last term minus the first term, we get 7, and add 1 tells us that in this series we have added together 8 terms. So the sum of those 8 terms will equal 8 times the first term, which is 7, plus the last term, which is negative 14, and we'll divide that by 2. So the sum of these terms is going to be 20. Number 7. The first term is 4 times, we're substituting 3 in for x, plus 1, so 13. The last term, we'll substitute 7 in. 4 times 7 plus 1, 29. Then the total number of terms in the series we'll have last term minus the first term and add 1. Now we can substitute. S sub 5 will be equal to 5 times the first term, which was 13, plus the 29, which is our last term. We'll divide that by 2, and we get 105. Number 8. We have our first term. We'll take and substitute 5 in for n. And we get 5. Then the last term, we'll substitute 15 n for n. And we get negative 15. Then we can find n by taking and subtracting 15 minus 5 and adding 1. So the sum will be 11 times our first term, which was 5, plus our last term, which was negative 15, divided by 2. Negative 412.5. Taylor borrowed some money from their parents to go on a trip. They agreed to pay back the $50 at the end of the first month and 15 more each additional month for 12 months. How much will Taylor pay in total after the 12 months? So we need to find out what was the first term. That would be how much they paid after the first month. So $50 at the end of the first month. Then we need to figure out how much did they pay at the end of their 12 months. And in order to find our last term, we are going to have to use our arithmetic sequence formula. The formula for the nth term is a sub 1 plus d times n minus 1. So right now we're looking for the 12th term. We have the first term plus our common difference would be the $15 added every month times 12 minus 1. So at the end of 12 months, they paid $215 that month. Now we need to find out how many total terms are we going to be adding together. That is 12. Now we can substitute into the formula. The sum of those 12 terms is equal to 12 multiplied by the first term plus the last term and divided by 2. And we get they paid a total of $1,590.